Resultant of concurrent system of forces in space. In the previous video lectures, we have discussed about the resultant of coplanar and the concurrent system of forces. Now let us discuss about the system of forces which are non-coplanar and concurrent. Non-coplanar means forces lie in space. Concurrent means all the forces pass through a single point. Now in this, let us first resolve the force lying in space into components. We have seen in the previous lecture that if a force is lying in a plane, then we can resolve that force into two components. The two components are mutually perpendicular, and we call them as rectangular components, because it is easier to find out the magnitudes of the components if we resolve a given force into rectangular components. So similar way here also, in case of the force lying in a space, we can resolve that force into rectangular component, but now we are going to have three components. In case of the force lying in a plane, we have two components, that is x component, y component, which are mutually perpendicular. Now in case of the force lying in a space, the components are three, and they will be x component, y component and z component, and all these components are mutually perpendicular, so we call them as again rectangular components of the force in space. So let us find out the magnitudes of those components. So here consider this figure. So a force F is acting in the direction from O to A, as shown here. A force F is acting in the direction O to A, and this force or the line of action of this force, that is OA, making an angle theta y with the y axis. Theta y with the y axis. So it is lying in a space, it is not in the plane, it's something like this. So if you consider this plane as the x-axis and this line as the y-axis, then it is not lying like this. OA line is not like this. If it is lying like this, then we say that it is lying in a plane, then we can resolve into x component and y component. But it is lying like this. The force OA direction is like this, which is in space. Now we need to find out the rectangular component of this force, and this force line OA making an angle theta y with this y axis. This is our y axis. This angle is theta y. And this force F is lying in a plane, that is which is like OBAC. OBAC is the plane in which this force F is lying. It is not lying in the xy plane, it is lying in a plane that is in OBAC. Now that is now this OB, line OB and line OC are perpendicular. Like we have in a plane x-axis, xy plane, x-axis and y-axis perpendicular. Similarly here also, in case of this OBAC plane, OB and OC are perpendicular, and this OA line of action of this force F making an angle theta y with this y-axis, that is with this OB line. So if we resolve this force into two components, then one will be along this line OB, other one will be along this line OC. So that is what is shown here. The next figure, resolving the force in the plane OBAC. If you resolve this force F, which is lying in the plane OBAC, then one component will be this, other component will be this. As this component of this force F is along this y-axis, let us call this component as Fy. Call it as Fy. And the other component, which is now OC, let us call this as some say FH. Now since this Fy is the component of this force F made with this y-axis, and this theta y is the angle made by this force F with this component, it will become cos component. That implies Fy is equal to F cos theta y, and Fh because now this angle is 90 minus theta y. See here, OA is making an angle theta y with the y-axis and 90 minus theta y with the line OC. OA is not making an angle 90 minus theta y with the x-axis. Here line OA is making an angle theta y with the y-axis and 90 minus theta y with the OC line. Theta y with the OP line, 90 minus theta y with the OC line, not with the OX, that is not with the x-axis. Why? Because it is lying in a space. If it is lying in a plane, xy plane, then theta y is the angle made by this line OA with OB, then 90 minus theta y will become the angle made by this line OA with x-axis. But in this case it is lying in a space, and we can consider that a force lying as that plane. Here OBAC is the plane, OB and OC are mutually perpendicular lines, and here OA is making an angle theta y with the line OB, then OA will make an angle 90 minus theta y with the line OC, because OB OC are mutually perpendicular. Then FH will become now F sin theta y. So, and coming to here, now that's what is shown here with this block sketch. This component here, the direction of the force F with respect to this point O is away. So the two components of this force, that is Fy and Fh, also must act away from this point O. So I have shown arrows, both arrows as of the components as away from this point O. Fy component is this, Fh component is this, and this angle is given as theta y. Now let us say this Fh is lying in the now coming to this Fh component. Fh component is lying in the xz plane. Fh component is lying in the xz plane. So we can further extend this. So it is lying in the xz plane, and say given that this angle made by this Fh with the x-axis as say pi, angle made by this Fh force with the x-axis is pi, then we can resolve this Fh in this plane. Then one component will be this, other component will be this. So if we show this again, all these components here in this third figure, here in this figure already we got this. And this is Fy. Now we have resolved Fh, which is lying in the xz plane, into two components. One will be along x-axis, other will be along z-axis. Then they are, this is one component and this is other component. And here the direction of this force Fh is away from this point O. Both the component directions also must act away from this point O. Now the components are, already we have named this component as Fy, and now here finally this component is acting along x-axis. We call it as Fx, and we call this as Fy. And this angle given, now we have replaced this Fh by these two components. So I will not show this again here, only by dotted lines, and this angle is given as some pi. So now Fx will become Fh is making an angle pi with this component, so it will become cos component. That implies Fx equal to Fh cos pi, and sorry, this is not Fy, this is Fz. This is Fz. Then Fz, because it is acting along the z axis, and Fz is equal to Fh sin pi. Now substituting Fh value here, so finally this is equal to F sin theta y into cos pi. Similarly here, this is F sin theta y into sin pi. Now we consider this fh square because this fh square, this is fh and this is fx and this is fz. So we can write that that is oc square is equal to, if you name this one a b o a b c, this has some d point here, this has some e point here, then oc square is equal to od square plus dc square. This is rectangle, sorry, this is a right angle triangle. So oc square is equal to od square plus dc square, and oc square means nothing but fh square, and od square, that is equal to fz square, dc nothing but